Okay, our last session before the big test. To start with, there are four major kinds of things. There are some things that are just identities. You just simply have to know, like, what could you replace with this? And we'll do a little practice on that. Then there's simplifying, which is just plain take this expression and simplify it down. It doesn't have an equals or an answer. The solve kind is where you want to set it equal to 0. Listen. Get it down to one function if you can, if I can get it all down to sine or something. But sometimes you can't. Sometimes you have to have two functions in it, and I'll show you how to do those in a minute. Proving was, I think, is seriously one of the easier parts, even though there are 3 questions, because you know that just by swapping identity stuff, it will have to equal what it says. You know that the answer is like tangent squared. You just have to keep simplifying until it gets there. All right, so here's a quick summary of the general kinds. The identity questions. See if you can get 7 out of 7 of what could we replace each of these things with. I'll pause while you answer those 7 questions on your paper. Okay, by now we should be done. Here we go. Number 1. Number 1 is 1. Raise your hand if you had 1. Okay, good. Number 2. Secant. That's related to this thing, right? And you divide everything by cosine. And I don't want to keep doing that, but bottom line is it turns into tangent squared theta plus 1. Raise your hand if you had that one right. Good. On to the next one, cosine, and this is a cofunction one. What's the cofunction of cosine? Sine. And then if the opposite thing from that is theta. I drew that wrong, but that's supposed to be a theta. Sine theta. Raise your hand if you had that one right. All right. Some of you aren't raising your hand ever. Does that mean you don't seriously have all the answers? All right. On to number 4. 1 minus sine would be what? Cosine squared. Number 5. This one, the sign does stick when it's sine and tangent. And so it would be negative sine of theta. All right. No parentheses needed. Forget that. Number 6, cosecant. That's 1 over sine. And the last one, 3 different options. Cotangent, but 1 over tangent. Cosine over sine. And, oh, what did you say on the last one? Tangent is the one that goes with cotangent of pi over 2 minus theta. I just asked what you said, and you were all like, oh no, I must have did it wrong. All right, so. Moving on. There are a whole bunch of base things you need to know, and I'm just going to tick through them. I had several kids get a aha moment out of the other class, like, oh, I didn't know that one, because I'd gone through a lot of things over the last few days. So here are some of them. Get it all into sines and cosines if there's no other way to do it. If you can get all down to sines and cosines, things tend to cancel out, and if your answer has just a sine and a cosine left, like right next to each other, then you're not going to be able to cancel those, but a lot of times that's a good trick that works. Difference of squares. For instance, you got to be able to do this. How do I factor that? On your paper right now. It's got to be like an automatic. Here we go. X squared minus 1, x squared plus 1. But how many of you remembered to go even farther? X plus 1, x minus 1 on that one. X squared plus 1. Do you get what I'm saying? This is also a difference of squares. So there's your final answer. Now what if that had been, instead of 1 on the right is a plus, and a difference of squares is only the minus part. All right, so then this part right here, a lot of people forget to take it the next step. So if that had been a sine x with a little 4 there, sine to the 4th instead of sine squared, minus 1, it would have broke down exactly the same way. It would have broke first into sine squared of x minus 1, and then sine squared of x plus 1, and then that one would have broken down too, if you needed to. If you could have just substituted in something else, you could do that too. But all right, anyway, I'm just trying to remind you, difference of squares, factoring is important. Moving on. Factoring, canceling, that kind of is what we were just talking about there. But one thing that people still seem to not be sure about is this kind of thing. Times cosine of x minus sine of x equals 0. If I had to solve this problem, I'd need to factor that sine out to the front. And it becomes like this, sine x, and then what's left? Cosine x minus 1, exactly. Okay, why is that good? Because now I've got my two parts. Whenever something's factored, you can say this equals 0 or that equals 0. And I can solve this side and say, well, it's sine of some angle equals 0. And I can do this side and say cosine x minus 1 has to equal 0. So I add 1 to both sides, and I have cosine of x equals 1. And then that has two answers, probably too. Okay? Canceling. You can cancel stuff, but not always, not everywhere. Let me give you an example of something you can't cancel. Watch. There is a nice simple equation. 2a equals a. It's something that I don't think about very often, but if I divided by a on both sides, it seems like it should be allowed, but you can't. You can only divide or multiply by numbers, not by variables. Because what happens when I do divide by a? That cancels and turns into a 1, and 2 equals 1. How genius is that? So you can't do that. So if you can't divide by a on both sides, does that mean this is not possible to solve? No. I can subtract a from both sides. I can subtract a variable from both sides. 2a minus a is a, equals a minus a is 0, and a equals 0. You get that? So the moral of the story is that if I want to have variables on both sides, I can subtract them from the one side to get them all onto one side. That's okay, but don't divide by a variable. So when you have this kind of problem, I thought, just forgetting that little rule, that I could just go, oh, divide by sine on both sides. Well, what did I just do? I just divided by a variable. Even though it's really neato and this all cancels, it's wrong. Can't do that. Can't divide by a variable. Okay, so what can I do? I can subtract it. So I can subtract sine x from both sides. And sine x minus sine x makes 0. And over here I have, and some people wanted to cancel that. You can't. It's sine x cosine x minus sine x, and now we're back to that problem we just had a second ago. You'd factor the sine x out of it. Okay, but one of the things I wanted to point out is it's okay to subtract a variable from both sides. It's not okay to divide by a variable, or we could not divide both sides by sine. That'd be illegal. All right. Just have to break something to get your attention. That's good. All right, this one. Try a simplify. Oh, come on. This will be easy. I encourage you not to look it up in your notes, because you know you're not going to be able to look it up in the notes in the test. You don't have any notes for the test. So if you want to make it from scratch and remake the identity sheet of 26 things, I know you could. The vast majority of you got like 25 out of 26 or 26 out of 20. No, it's out of 25. 25 out of 25 or 24 out of 25 on that test. So you can do those, but you won't have the sheet with you. Well, what's that one? Cosine squared. Well, what's that one? Wait a minute. They're both the same thing. What's the answer? Raise your hand if you had 0. Good. On to the next one. Simplify that. And don't you dare go like this and go, oh, cancel, cancel. Can't do that. This is an add, subtract kind of problem. You can't cancel like that. You can factor things. Once they're factored, then you can cancel things. This is probably R2. It's a little too simple in R3. But if you added in one extra thing, maybe it would probably turn into an R3 level. It's close. It's right on that edge. All right. So I hope you noticed difference of squares can be factored then. So it's cosine squared minus secant of theta, and cosine squared again minus or plus, sorry, secant theta. All over, what was the denominator? That hasn't changed. Cosine squared theta plus secant theta. All right. So which one's going to cancel? The one with the minus or the one with the plus in it? The one with the plus. Cancel, cancel. There's your answer. Now some people say, well, you could have just canceled off these. Well, that's because this happens to be written with a plus on the bottom. If this had had a minus right there, if this right here was a minus, then the one with the minus would have canceled. And your answer would have been positive, even though there's no positive in here. That'd be a really sneaky test question to put on there, because kids that think you can cancel would just go, oh, cancel two of those, cancel off those, and you can't do it like that. It won't work, because your answer, what it should come out to, is positive. And if you didn't know this, if this was written with a minus, you'd think that the answer was cosine squared theta, and you only have minuses in the problem. You'd think it was minus secant theta, but it's actually plus if it had a minus on there. Okay, anyway, I might just change the problem for you next hour to make that a minus, because that'll keep people from thinking you can cancel that out. Okay, anyway, once you got it factored, then things will cancel. Moving on. Solve this one. Just showed you this a second ago. We'll see how long it stays in your short-term memory. I have to come out in their crowd with a ruler if somebody divides both sides by sine squared. Now this one, you got to set up both of these equations. This equals 0 and that equals 0. They're separate. This sine theta equals 0 is squared. How do I get that squared off of there? Because you really can't finish this problem until it's plain. You take the square root. Well, what's the square root of 0? 0. But it's supposed to be plus or minus 0, but isn't that the same thing? Plus 0, minus 0, same thing. So it's just sine theta equals 0. How do you get that answer? If you can't do that, you're in trouble. You got to be able to make a triangle when there is no triangle. So it must be one of these points, right? So then these points are over 1 up 0, over 0 up 1, over negative 1 up 0, and over 0 and up negative 1. Okay, so which of those have a sign which is a y value of 0? The y value is 0. There and there, so it's there and there. And if the problem said in degrees, you could say what and what? 0 and 180. If the problem had asked for radians, you'd say 0 and pi. Nope, because it'll have a limit on it that it doesn't want it to be equal to. It'll be less than 360. Okay? You're good. You make a good point, though. 0 and 360 are in the same spot. But usually the limit's up to 360, but not equal to 360. Okay, so that's that side. And over on the other side, I'm going to do this side. Cosine squared theta minus 1 equals 0. I tried to do something last hour with switching that out with a sine, but I don't think you really need to. You could replace cosine squared with 1 minus sine squared. Okay, you could do that. But instead of that, why don't I just, okay, let's say I do that. 1 minus sine squared theta minus 1. In a way, it's kind of good to do it that way. Because what happens to the ones? They cancel, and you just have negative sine squared theta is equal to 0. Another way to think of it is that this right here is exactly like 1 minus cosine squared, except it's backwards. And so you could put in negative sine squared for that. You could, and you'd solve it for cosine, but it's not really easier, because what's this answer going to be? What's negative sine theta equals 0? It's the same as sine theta equals 0. And didn't I just do that over here? You want to go do it all again with a cosine thing? You get the same answers, 0 and 180. But see how this is the exact same thing? No sense in doing it twice. All right. So if you'd have gone through and done it with cosine, it would have been good in a way because you'd have had the practice, but it would have come out with 0 and 180 again, because it's the exact same thing as sine. All right. Wait a minute. You said you did the cosine one? All right. So what did you get? Did you get 0 and 180? Okay. Well, then you did it right, so you're good. All right. Moving on. This one. Even though I don't see any squared thing anywhere, as soon as I make the first substitution, try to make them all into the same sign, and signs, if you're picking what to change it to, change them all to sines and cosines, right? So then you should change this to what? Sorry, I put the parentheses in the wrong spot. This to 1 over sine. No, wait. So this turns into 1 over sine. Now I'm going to have to do what to fix this? Times everything by sine. Why am I doing that again? Let me just rewrite this thing how I'd want you to show the work. And hopefully at this point you'd realize you have to get rid of this denominator of sine squared, and the way to do it is to multiply everything by sine. And how many of you remember I've done this same problem before? Okay, good. Because it turns out to be a quadratic. 3 sine squared theta plus the sines cancel. This sine cancels this sine, and I get 2 plus 7 sine theta. I'd like you to solve that one from there. I don't want to make that mistake as a teacher of assuming, oh, you know what to do now. Maybe you don't. I don't know. Try it. Specs today. This would be more like an R3 level. So we go 3 sine squared theta plus 7 sine theta plus 2 equals 0. I just rearranged it, that's all. You wouldn't even have to. But I think it makes it easier to factor. And then you go 3 sine theta plus, and sine theta plus. And then I just got to figure out what number goes here and here. That multiplies to 2. Well, it's got to be 2 and 1. So I go 2 and 1, and I see if that works. That makes 3 times 1 is 3, plus 2 would make 5. That's not what I wanted. So if it doesn't work the way you want, you switch it around. 1 and 2. 3 times 2 makes 6, plus 1 makes 7. Yay, I've got it. And then, did anybody notice that one of these two is impossible? This one here, when you get it down to this, you should go, oh, you can't have sine ever get any bigger than 1 or smaller than negative 1. So you cannot figure this one out. It'll go like this, and the 1 is the highest it goes, and negative 1 is the lowest it goes, so we'll never do that. So you say what? Undefined. So that part's done. Over here, 3 sine theta plus 1 equals 0. 3 sine theta equals negative 1. Sine theta equals negative 1/3. And then the problem here is that I didn't set this problem up terribly well because you can't do this one in your head. You'd have to use a calculator because it ends up being a triangle with one side is 1 and another side is 3, and the other side you can't figure out. Know what I mean? I mean, you can figure out how long it is, but you couldn't figure out the sine of that angle. So you can't figure out what angle it is. So bottom line is this one you need a calculator for. So I guess you can't really totally finish it. At least would you know this? Which quadrants would it have been in? The T and the C. And your calculator with an inverse button would have been able to tell you the answer. But all right, let's say that it had come out to be 22. I could really see a kid just writing down the answer of 22. But it's not really 22, is it? 360 minus the 22. And this one over here, that's 22. It's not really 22, it's 180 plus the 22. Okay, moving on. A prove question. The nice part is, you know that it comes out to that. If you do it right, you know. Well, sure, it looks scary, but I'm telling you, after like one little substitution, maybe two, it'll be totally obvious. That's easy. Nothing. Okay, Mr. L, give me something to start with. That'd be you. I like it. Now, what you'd have to do is rewrite the problem with that in it, in one step at a time. Don't try to just jump to the ending. I know that the answer is negative tangent squared theta equals negative tangent squared theta. That's the ending, duh, because it's a proof. So of course it has to end that way. But you have to show me the steps along the way. You can't just jump to the answer, of course. So you write down one step at a time. Now there's one step. Act like I just wrote all of the black writing plus the blue. And then I'm going to write the next step. Wouldn't this part right here be negative tangent of theta? And so then the tangent of theta over tangent of theta can cancel. And I'd make negative 1 over cotangent squared theta. And that is, I could put the negative out here. That is tangent, so it's negative. And that's exactly where I'd get this. Negative tangent of square root of theta. All right. The ultimate challenge one. The other day, we did this one, and the key to it was nobody knew where to start on this thing, so I suggested that you do something, and by now I hope you can just see it. Factor it. What do you factor out of it? Sine. And then you've got two things being multiplied equaling 0, so this has to equal 0 or that has to equal 0. Once that sign comes out, I have 2 cosine squared theta minus 1 in the inside. Okay? So you'd set them both equal to 0 and solve them both. This one will probably have two answers. In fact, we already did that one before. What's sine theta equals 0? I told you the two answers. 0 and pi, if you want to do it in radians. And then this one, you'd have, I just better not skip any steps. 2 cosine squared theta minus 1 equals 0. Add 1 to both sides. That'll make this one go over here. Then divide by 2 on both sides. And here's the part where I know some of you are going to lose a point because you're going to forget the plus or minus. Square root. And then the plus or minus 1/2 thing. Some of you are going to get stumped on that, but we've talked about it enough, so I have a feeling that on the problem that's kind of like this, that you'll think about What's the square root of 1? Over square root of 2, do you know that one? No. But have you ever seen that before? Yes, you have. It's really root 2 over 2. And you know which triangle you're in if you got a root 2 over 2? The 45. Okay. That's this guy. Root 2 over 2, root 2 over 2, and what would this one be right there? 1. That's the triangle in question. So 45, 45, 90, except it's been morphed so that it doesn't have the square root of 2 here anymore. Yep. Well, it would have 2. Yes. It will have at least 2 answers, but it could have 4. Usually you have 2 for the one that's positive and 2 for the one that's negative. In this case, I know it will have 4 answers, yes. Okay, so that had 4 answers. This had 2 answers, so this one has 6 answers total. That's right. No credit. All right. I still predict that we will have half this class will get straight A's. Half of you will walk out of here with a 95%. There'll be another, like, 1 kid will probably figure out the R4 too. Then there'll be a bunch of you guys that are just, this is just too much, and you'll probably get C's. And that's okay. But you just do your best. And you absolutely try for it, because they are all doable. They really are. I really believe that at least half of you can pull off the A's, and I'd love to see it be, you know. Well, there is times when there's only the 1 kid who doesn't make it. Yeah. All right. Okay. We already did ones like this, but you remember what to do? This is off that little homework quiz we did the other day. Remember what to do with this big jumble on the bottom? Yeah, somehow. How? This and this could go together and make what? 1. And then this does not make one of those identities. So don't try to, like, let that be an identity, because it's not squared. All right, if there'd been a squared there, then we could talk about rearranging it so that it could make it an identity. But if it's not squared, if it's just like cosine minus 1, don't try to think that that's a quadratic one or a Pythagorean one. It would need to be squared to be able to be replaced. On simplify, you still need to show steps, yes, but it's not as intense as the proving ones, because the proving ones, like simplify one, you don't have the answer sitting there. You know what I mean? When it's prove, you've got the answer sitting there, so obviously I know the answer. You've got to show all the steps, every single one of them. Okay? So that's what it's like. Question is whether or not you are going to take the time to study now, because the test tonight or tomorrow is the hardest test you've had, no doubt. And if you really want the A in this class, I know there's a lot of people going to be riding that borderline between B plus and A minus, or between A and A minus. This is the type of moment when you make that decision, whether you're going to get the higher grade or not. Is it worth it to you or not? And I would propose that it is worth it. All I'd ask you to do for tonight, that's kind of your studying, is to finish your homework that you already have. The answer key is not posted yet, but will be posted tonight, so you can look through every single step and make sure that your answers, on the simplify ones, if you got the right answer, I'm sure you probably did it right. But look at your proofs and make sure your steps are shown just like the teacher would have done it. You can even do it in a different order as long as you show your work. But double check your answers tonight on Blackboard. If you don't do that, that's just silly. I mean, that's like saying I give up. I'm not going to have a chance at this test. All right. Want to do this one? Okay. So we've got, it looks to me like as soon as I see this minus and I see these are like perfect squared kind of numbers, I'm thinking that I can have a difference of squares. So I can factor this puppy. Sine squared x, sine squared x, a plus and a minus, and the square root of this is what? Cosine squared x, cosine squared x. Well, that was too small or too big of a writing to fit in the thing. But anyway, I'm not going to do anything over there because I want this to just come out to the right thing at the end. All right, and what's this really equal to? So it's 1 times sine squared x minus cosine squared x. And isn't 1 times this the exact same thing as this? Which is equal to, bring it down. Easy peasy. No lemon squeezies though. They do have them at McDonald's. It's a lemon strawberry thing. It's pretty good. It's very sweet. I mean, you got to be able to handle intense sweet and intense sour in the same drink. It's kind of